We're looking at number 2 for limits continuity, AP FRQ review. This is non-calculator. The function f is defined as square root of 25 minus x squared, from defined between -5 and 5. First thing is find f prime. So f prime, we have to get this rewritten using parentheses so we can see that there's a need for chain rule. There's an outside portion versus inside portion. So we take care of the outside's derivative. So we bring down the 1/2, parentheses to the -1/2. So that's the outside portion. Multiply by the inside's derivative. So 25 goes 0, negative x squared becomes negative 2x. We clean this up and we have our f prime function written as a fraction form. Okay, part B, write an equation of the line tangent. So a tangent line, we're going to need order pair and we need slope. So the order pair, we can plug -3 into the original function, and that will give us root 25 minus 9, which is root 16, which is 4. We also need the slope. So the slope can be evaluated using the derivative that we found from part A. So we can plug -3 in for x. We get -3 over square root of 25 minus 3 squared, which is 25 minus 9, which is 16. So 3 over root 16 is the same thing as 3 over 4. We have our order pair, -3, 4. We have our slope, which is 3/4, and we put into point slope form. So y minus y1 is equal to the m value, slope times x minus x1. Okay, part C, we have our g function defined by g of x is on one side is defined by the graph f of x, and on the other side of 5, to the right side of 5, it's to the right side of -3 is defined as x plus 7. So the graph is split on either side of -3. Is the function continuous at -3? So we're going to go through our continuity conditions. The continuity conditions being, does the point exist? Does the limit exist? And if we have piecewise function, we may have to look at the limit from either side of C and then look at the results to see if they agree. And finally, the third condition is, if we have the results from the first and second conditions, are they in agreement? Does the point sit where the graph is leading to with the limit? Okay, so let's go through our conditions one by one. First condition is, does the point exist? So we're going to plug -3. -3 is defined because of the less than or equal to with the first piecewise. So we plug -3 into f of x. -3 into f of x, we get 25 minus -3 squared, which is root 16, which is 4. So our order pair exists at 4. Does the limit exist? All right, does the limit exist? That means we want to evaluate the limit from the left side of -3 with this piecewise, and then evaluate the limit from the other side of -3 with this piecewise. So we set that up. Limit as x approaches 3 from the left side of 3 with the first piecewise. Plug that in, we get 4. And then we also evaluate the limit from -3 from the right side of -3. Now, the notation negative and positive just indicates that we're approaching from the left side of 3 and from the right side of 3. But algebraically, we're not going to do anything with decimals. We're just going to plug those 3 in. So 3 plugs in for x. Sorry, -3 plugs in for x. We get -3 plus 7, which is 4. From the left side is 4. From the right side of 4, we see that we have an agreement on both sides. Therefore, the limit does exist at 4. So now our third condition is just comparing the results of the first two conditions. The first condition gives us order pair of 1. Second condition gives us a limit of 4. We see that both those results are the same value. So the third condition is going to be true. G of -3 does equal to the limit as x approaches -3 from both sides. So if they are in agreement, that means all three conditions have passed. We have therefore confirmed and justified that our function is continuous at x equals -3. For part D, find the value of the antiderivative of this definite integral from 0 to 5. So this is not something that we can expand and rely on power rule, so we're going to go through use substitution. But let's rewrite this integrand first with parentheses. So we'll convert that square root to parentheses to the 1/2. Our u value is nicely stored inside the parentheses here. We'll let the u value be what's inside the parentheses, 25 minus x squared. We find the derivative, 25 goes to 0, negative x squared becomes negative 2x. Cross multiply, solve for dx, we get dx equals du over negative 2x. And now we make our substitutions. We're going to apply u sub here. So parentheses gets replaced with u. Dx gets replaced with du over negative 2x. X's go away. We push the negative 1/2 in front. And now we see a clear power rule that we can apply here. U to the 1/2, we apply a power rule. We add 1 to the exponent. So that becomes u to the 3/2 over 3/2. We push that 3/2 up as 2/3. And we're going to convert it back in terms of x. And once we've done that, then we can safely apply our upper and lower bounds, since we're going to try to get a numeric answer out of this. So 5 plugs in for x. We get 25 minus 25, which is 0. All this will go to 0. Then we plug 0 in for x. Careful, 0 in this case is not going to wipe everything out. 0 plugs in for x is going to take this out, but there's still leftover terms that will result in a number other than 0. So 25 minus 0 is just 25. 25, we can evaluate this. Square root of 25 is 5. 5 cubed is 125. 125 over 3 plus 0 is just 125 over 3.